Hello friends, welcome back. In this session, we'll quickly understand the challenges that we have in the hardware Trojan detection. First one starts with incomplete coverage. The current techniques which we have in hand, like the functional testing or the side channel analysis, are often effective only against specific types of Trojans. For an instance, functional or active Trojans. The challenge here is the techniques as the logic testing can detect only functional changes, but it could miss the parametric or passive Trojans that do not alter the device behavior under normal conditions. The second one is coming here, high false positive and false negative rates. The current methods can yield false positives, indicating that the Trojans were there and effectively none were there. Or it can be false negatives. It can fail to detect the Trojans which are present there strongly. So this way, the challenge is making it more reliable. We are mistakenly flagging harmless variations, thereby we are slowing down the production and the process and indirectly increasing the costs as well. This is a major challenge. Next comes the sensitivity to the environmental factors. The techniques which we are very familiar with, like the side channel analysis, are very highly sensitive to the environmental factors which include noise or temperature or electromagnetic interference. The challenge connected is this dependency can reduce the accuracy which we are pretty much bothered about. And most importantly, in the industrial infrastructure and the setup, external factors vary definitely and widely as well. This can lead to unreliable results. So we have to be careful. This is a challenge. Limited applicability for the complex designs is the next challenge that we have. The chip designs are becoming more and more challenging. It becomes more and more intricate. So detecting the subtle Trojans amidst the complex circuitry is very challenging. In fact, that's more challenging than designing the chip. Modern integrated circuits have billions of transistors, so it is very comprehensive. Testing and identifying the Trojans inside that is going to be very troublesome and challenging. Then comes the dormancy and the conditional activation. Many Trojans are designed which can remain inactive for a long time until triggered by specific conditions. So, a sequence of operation or sequence of instructions or an unique input pattern only can activate them. Until that time, these dormant Trojans can evade detection under regular testing. So, they will get activated only under certain conditions. So, they are almost invisible until then and they will not be detected in the standard testing environment. The adaptive behavior is a major challenge. The modern day Trojans are capable of hiding during the testing phase. That's very, very difficult for us to catch it without highly specialized testing environment or infrastructure, and that's going to be really challenging and troublesome. The tiny physical footprint is another major challenge thrown at us. Many Trojans have got very small, minute footprint, and that can alter only few transistors or circuit path. That is very difficult for us to detect through optical inspection or electrical testing. The main challenge here is the small changes are very hard to be distinguished from the normal manufacturing variations, particularly in the devices with billions of transistors. It's going to be super challenging. Continuous insertion points is the next challenge that we have. Trojans can be inserted at design, manufacturing, or post-production. That way, it's going to make it more challenging to establish a single strategy which can detect and covers all the possibilities. Trojans inserted during the design can affect the entire chip, while manufacturing time Trojans might exploit the backdoors or modifications invisible in the design phase. That way, it's becoming even more challenging. Then, high cost related factors is a major challenge. Detecting Trojans require extensive infrastructure. It needs specialized equipment. It needs definitely equipment which are going to be costly. They are going to be expensive, which cannot be afforded by everybody. And the challenge here is high cost makes it very difficult for the companies to implement comprehensive testing across all units, particularly for large scale production. So it's a major, major challenge that we have in front of us. Scalability challenges are also in line with us. In the large production runs, testing every individual unit for Trojan is almost a nightmare. It's impossible. So, current detection methods are often too time intensive and it is not possible for us to take each and every unit to go ahead and test it for Trojan. That's very difficult. Finally, the trade-off between the cost and the detection accuracy. There is a trade-off between the cost of detection and the thoroughness of the Trojan identification. Low-cost testing might only catch most obvious Trojans, while the sophisticated tests and techniques can drive up the manufacturing expenses, and it may not be affordable by everybody. The companies are often forced to balance the risk of undetected Trojans with the additional cost for the rigorous testing. This is one of the most important challenges that we have in front of us, which can impact the product pricing and the accessibility. All these challenges are there for you when you look at into the hardware Trojan detection, and that makes life even miserable. If you have any questions, please go ahead and type it in the chat section. I'll be happy to answer. If you like the channel and the content, please subscribe. Thank you.